Okay, March 12, 2025, Physics 7. I will start sharing my screen here with you. Okay, so today is electric circuit number 2, lab 2, okay? Let's see, we're going to continue with the topic on electric circuit for the first hour, and the 2 remaining hours is going to be lab number 2. In addition to that, the report for lab 1 is due now, and I will document that in my notes. So March 12, 25, Wednesday, and that's week number 4, right? Let's double check. It's week number 4. Oh no, it's week number 5 already. Week number 5. Let's take a look at this one if this one is right. Oh yeah, week number 5. That's correct. That's good. Electric circuits. And let's see what we cover. What was the last thing we covered on electric circuits? We were covering, okay, resistors in series and parallel. Okay, that's what we're doing. Can you memorize those equations easily? Resistors in series, results in an equivalent resistance equal to the summation of all resistors. Now, if you connect the resistors in parallel, the inverse of the equivalent resistance ends up being equal to the inverse, to the summation of the inverse of the resistance of each resistor. It is very important when you're working with circuits, either in electronics or electricity. And if you're going to end up doing any research and developing new devices, new gadgets, right? You're going to need to know that stuff. It's a very basic thing that you have to know. I do research, and I do not know as much as I wish I knew about electronics, okay? And because of that, because of my lack on electronics, lack of knowledge in electronics, I struggled big time with my own technology when I started developing new sensors. When I was working at NASA, I struggled big time. I'm at the point that I have to hire someone that knows electronics to do the devices that I want to be done. And if you're going to follow the same career on, scientific career, for instance, developing new equipment, you will certainly need something like that. You certainly need to understand something like that, right? So let's get the other things here. Illustrations. electric field, electric capacitors, electric circuit, right in here. Okay, so let's just quickly review. More students coming in. Here you go. And also, let's take a look at the book, just so we follow the book according to the order that is in there. That's Electric Circuits, chapter 20. Electromotive force, Ohm's law, resistance and resistivity. Right in here, resistance and resistivity. Series wiring. For now, we are skipping those two sections, series wiring and parallel wiring. Series wiring of resistors. He's not doing series wiring of capacitors yet. Okay. And we also have the power. See here. Parallel wiring. Okay. Here's an analogy between parallel wiring, between an electrical circuit and a water circuit with a pump, the pump doing the job of the battery. Okay, so here we go. And then we can solve some problems, okay? Let's see, circuit wire partially in series and partially in wire. Then you have also the combination, right? Partially in series and partially in parallel. This chapter is very extensive and is very important too. Okay, so let's do some examples of circuits in series first. We already did one, right? Let's see. Here you go. Here you go. The simple circuit that you're going to see out there. And now the next simpler circuit that you're going to see out there. Two resistors in series, right? The two resistors in series can be written down in terms of a circuit with a single resistance. And this, by single resistance, I mean by a single equivalent resistance, like that. Is R1 plus R2. Okay. And what else you have to know? You have to know that whenever you have the two circuits in series, and I mentioned that before, the voltage across each of the resistors, the sum of the voltage across each of the resistors must be equal to the sum, must be equal to the voltage provided by the battery. Okay. And the current is going to be the same throughout all the resistors. The current is going to be the same throughout all the resistors. Okay, in parallel is exactly the opposite. And how do you visualize the circuit in parallel? Okay, here you go. That's how we draw the resistors in parallel. They are actually in parallel, right? It's no, you know, it's no wonder that we call it circuits in parallel. So here you go. That's another way of illustrating the circuit in parallel. Okay, another way, just a different orientation. And what you have to know that the current, when it exits the battery, you know, you have this current of electrons, right? They are moving in this circuit. The original current we are calling I. Now, when the current reaches this intersection here, it's just like a fork in the road for cars, okay? Some of the cars goes in one lane, the rest of the cars goes in the other lane, right? Or let's say some of the current goes in this direction, the rest of the current goes in this other direction. And the sum of those two currents in the two different lanes, right, or in the two different branches must be equal to the net current that we have from the battery. Can you remember that? That's the principle of conservation of electric charges. And that's what the next slide is all about. Okay? At the intersection here, we have some of the current moving through the first resistor, the rest of the current going through the second resistor. And I1 plus I2 must be equal to I. Okay? I1 plus I2 must be equal to I. And I'm going to write that down here. I equal to I1 plus I2. Copy and paste that right here. Like that. What else do we have? What else do we have? We have that because the ends of each resistor is directly connected to the wait a minute, there is a problem here. There's a mistake here. Here's negative, right? Directly connected to the terminals of the battery. Okay, the loss in potential energy between those two ends of the resistor. We say the loss in potential energy because the resistor generates heat, okay? It's just like your lamp, your old lamps, right? Not the LED lamps, but the lamps that Thomas Edison invented, right? And they produces heat. And that heat comes from the potential energy provided by the battery, the electrical potential energy provided by the battery. So the loss in potential energy across this resistor 1 is going to be equal to the potential energy provided by the battery. Similarly, we get the same thing here for the resistor number 2. Okay, we get the same thing here for the resistor 2. And I want to copy this one here and paste right in here. Even better, I'll copy that and place right in here. Okay. Now, another mistake here that I gotta fix. And now when I combine those two resistors in parallel, we end up with an equivalent resistance. With this equivalent resistance that's given by that equation that you saw, okay? The inverse of the equivalent resistance is equal to the sum of the inverse of the resistance of each resistor. That's easy to remember, right? Equivalent resistance of a set of resistors in series is equal to the summation of the resistance. Equivalent, the inverse of the equivalent resistance of a set of resistors in parallel is equal to the summation of the inverse of each resistor. Simple enough, right? So here you go. Now going back to the resistors in series, if you have 3 resistors in series, okay, what do? We apply, right, that rule. Here you go, we can combine those 2 resistors. I'm going to do the following. I'm going to do exactly what I did before, right in here. I'm gonna get this box here. So it becomes more, here you go, this box right in here. Another student come in, right? And it's going to be equivalent resistance R12. That's what I'm calling it, right? In the next slide, we are going to have another box like that, but which is going to encompass the remaining 2 resistors, right? And that equivalent resistance, I'm going to call equivalent resistance R123 in the next slide. Did you see the notation that I made it here? R12, right? R12 is equal to R1 plus R2. And in the next one, we are going to have equivalent resistance R123. That's for 3 resistors. And we, the current is going to be the same through each of the resistors. It's just the electric potential that's different. Here you go, another example. 3 resistors in parallel. 3 resistors in parallel. Here you go. The current is flowing in this direction, right here. Okay. R12. But before we go to R12, let me just emphasize, right, that when the current reaches this node, right? We call it the node. I'm going to when the current reaches this node right in here, that's the name of this intersection. That's the name of this junction. Okay. What's going to happen? This current is going to split. This is going to split as a current I1. I'll call it I1. And this current is flowing in the other direction. Right now, I prefer this arrow. Let me change the arrow here. I like this arrow better, this tip better. It's nicer, right? So let me shift the ego. This one, the same thing here. Looks much nicer, right? But then I have to shrink this current, right? Because this arrow, I have to shrink this arrow because this arrow is smaller than the original arrow, than the original current. And then after on this direction here, we have another different current. Ooh. Current that I'm going to call current I23. It's a very nice notation. I have to shrink this current, right? This arrow, I have to shrink this arrow. I1 plus I23 must be equal to I. And let's not forget that we already have another node here. I'm gonna make it a little bit longer. Can you picture that? Okay, try to picture electrons moving through those branches of the circuit. We are going to have current I23 right here. No, oh, sorry, not I23. It's going to be current I2, right? Because it's going through the second resistor. Yeah, I2. It's nothing, the size of the arrows is not realistic, okay? I'm not worried about getting the right size of the arrows. And, okay, we have this other arrow going through resistor 3, another current arrow, right? I3. That's how you should visualize all those currents. Okay, let's get another one. And then very soon we are going to worry about the equivalent resistance, okay? Very soon we are going to worry about the equivalent resistance. Right now, I just want you to have this picture, this mental picture of the current flowing through our circuit. The current doesn't change because the electrons are not jumping out from the wires. We are talking about a circuit in which there is no loss in charges. Here we go. I'm gonna copy all the stuff, paste it, and put on the other side. Okay, why is this one's not supposed to be here? I gotta change the direction of the current because now it's on the other side of the circuit, right? Here you go. Change the direction of this current because it's on the other side of the circuit. And it's still going to be I23. See that? And this one here. Change the direction of the current. Okay. I am going to put on the other side. I'm not, like I said, I'm not doing the equivalent resistance yet. I'll do that very soon. And I have to get another one here. Oh, like that. Do you get the idea? Let me cut down this one short. Short. Okay. At this junction, I3 combines with I2. And I'm going to write that down here. We go. I1. Let me go in the other one there. So it makes easier for me to Yeah, this one that I want. Times New Roman. What about this one here? This one is Aptus. Let's put everything as Aptus. Font. Aptus. Here you go. So bold-faced. Okay, let's put everything bold-faced here. I1 plus I23. Okay, I1 plus I23. I1 plus I23 is I. And I23 is equal to what? I23 is going to be equal to I2 plus I3. Okay. And I is going to be I1, I2 plus I3, right? Since I23 is I2 plus I3. That's the best drawing that I can make for you. Okay, going back to our resistors in parallel, right? Going back to our resistors in parallel. Here you go. Like that. I'm gonna get my little box. Let's use this one here. I'm going to combine resistors 2 and 3. And when we combine resistors 2 and 3, we end up with resistors 1 and 2, right? I'm going to combine resistors with 1 with resistor 2. We end up with resistor R12. Okay? And now that we have resistor R12, we are going to have a slightly different current. Let me get that. I do not know what this one is doing here. Here you go. I have resistor I. Now it's going to be slightly different. It's going to be, the current now is going to be current I12 plus current I3, right? Make sense? Okay, and everything is very, logical, and it's not a difficult thing to memorize, right? And then what comes afterwards? What comes afterwards? Let me get another one here, so my drawing doesn't get too busy. At the junction, here we are going to have current I3, current I3 only, right? Shrink it a little bit, and I'm going to need current I12 in that little branch. Here you go, current I12, because it's two resistors in parallel. Two resistors 1 and 2 in parallel. There you go. Like that. And it's exactly the same thing that we got before, right? At this other junction, current 1, 2 combines with current 1, I3. Okay. And now we have to combine those two resistors in parallel. Just like I did before, I'm gonna draw a box around those two resistors, right? And we end up with resistor R123, where the inverse of the R123 is going to be equal to the summation of the inverse of R1 plus the inverse of R2, the inverse of R3, and so on. Okay? We did that already, right? Different. Okay, this is supposed to be minus I1. I minus I1. Okay. Okay, now we have resistors, a combination of resistors in series with resistors in parallel. What we have seen so far, let's write it down here. Electric circuit. Last time, what we saw was just circuits that had resistors either in series or in parallel. Okay. Now we will see what happens when we combine resistors in series and parallel. See the difference here? We have resistors in series and parallel in a single circuit, right? Or in parallel in a single circuit. That's what here. Or and, right? That's the difference. Oops, not this one. I want to get only the or here. We saw here one circuits had resistor either in series or in parallel in a single circuit. We saw, or in parallel, we don't need that anymore, right? Now that I changed it. And two, last time we saw a circuit that had resistors that had only resistors in series. Okay. And circuits that had only resistors in parallel. Okay. Now we'll see what happens when we combine resistors in series and parallel in a single circuit. That's the next level of difficulty, right? So here we go. Levels of difficulty in solving problems in circuits, right? 1, circuits with a single battery and a single resistor. That's the easiest circuit that we're going to see out there. And I'm going to copy and, okay, that would be an example of a circuit with a single battery and a single resistor. Okay, I'm gonna use this one. Let's see, this one here. Oh, we don't need that. We can erase that. We can erase that, right? And what I'm gonna do, I'm gonna copy this circuit here and paste there in. I'm gonna do better than that. I'm gonna go a little bit down here. I have a nicer picture. Let's see. Yeah, good. Now I have here a nice picture, right? Copy and paste. A circuit with a single battery and a single resistor. Circuits. That's the one. That's the one is the circuit with a single battery and a single circuit. Circuit with a single battery and two resistors in series. That's the next level of difficulty, right? With a single battery and two resistors in series. Let's copy that. I will use this one here. I will use this one here. Even though it's just, let's see. I'm going to, no. So there's no confusion, right? I will put like that. R2, R12. Circuits with two resistors in series. Different levels of difficulty, right? Circuit with a single battery and two resistors in series, right? Pick up. Circuits with two resistors in parallel with a single. Why am I mention single battery? I'm mentioning a single battery because we can have circuits with more than one battery, okay? And two resistors in parallel. Let me put that here, circuits. Right? Let's get that. Okay, would be this one here. Different levels of difficulty. And two resistors in parallel. Solve a circuit with two resistors in parallel is more difficult, mathematically speaking, right? Than solving a circuit with two resistors in series. Okay. Etc. I'm gonna put it for etc. Right? Now etc. means larger number of resistors in the circuit, and 5 circuits with a single battery and a combination of resistors in series and parallel. Okay, resistors in series and parallel. That would be the next level of difficulty. Going back here, right here. Okay, let me copy this one. I'm going to erase those currents. Okay, so here you go. That's the next level of difficulty. This circuit that you see right in here. See, those two resistors that are in series, they in combination are in parallel with this third resistor. That's a combination. Okay, so how do we solve this circuitry? We get R1 and R2. We combine them. Okay, we cannot combine R1 with R3 because R1, the electric potential of R1 is not the same as the electric potential of R3. Okay, so R1 is not in parallel with R3. It is the combination of R1 and R2 that are in parallel with R3, okay? Is this end here that's connected to the end of R2, coincides with the other end of R3, and this end of R1 that coincides with this end of R3. Okay? So here you go. We combine those two circuits that are in series, make them R12. And now R12 is in parallel with R3. Okay. And we get the R123. The current flowing through this one is I call I12. The current flowing through this one I call I3. What's going to be the equivalent? Let's do that. Let's solve this one, right? Let's solve this circuitry here. Okay, we're starting with this one here. Find the equivalent resistance. I'm gonna put it. This one here. Example. Find the equivalent resistance of the circuit below. Okay, we go. This one right here. I'm going center justify. Okay, solution. So how do we solve that? First, we combine R1 with R2. When we combine R1 with R2, we get, I'm not going to use this current right now, but I will use it later on. First, we combine R1 with R2, right? So here we go. And I'm going to subscript it. First, we combine R1 with R2. Okay, and I'm going to write that down here. R1, I need my equation. Okay, right here. R12 R12 is equal to R1 plus R2. Okay? Then we combine R12, then we combine R12 with R3, right? Subscript. And we go get that. And I'm gonna do that without the current, so it becomes easier to visualize. Okay. R12, since R12 is in parallel with R3. So how do we solve the circuitry? We apply R13, I'm gonna do like that. I'm gonna put it, the inverse of R13, see that? Is equal to the inverse of R12 plus the inverse of R3. That's how we do it. Okay? That's how we do it. Uh-oh. Like that. And I'm going to write that down. I didn't finish yet. The thing is not finished yet, right? The inverse of R123 is what? 1 divided by R123, right? And I'm gonna 1, 2, 3, like that. The inverse of R12 is equal to the inverse of R12, right? The inverse of R3 is equal to 1 divided by R3, right? There's one more thing that we can do. We can write down R12. We know that 1 and 2 are in series with each other. So this R12 becomes R1 plus R2. Okay? We're almost there. We didn't finish yet. What we want to know, we want to get not the inverse of R123. We want to get the R123. To get R123, we have to invert the right side, right? We have to invert the right side of this equation. In order to invert the right side of this equation, we have to raise the right side of this equation to -1. Okay, we didn't finish the problem yet. Now, what else I'm going to do? I'm going to combine those two denominators, right? I'm going to put them under the same denominator. We go R3, right? Put under the same denominator. We end up with R3 upstairs. And what else? R1 plus R2, right? That's what we end up. We didn't finish yet. We still have to invert this ratio that you see right in here. And in order to invert, all I have to do is copy this one upstairs and copy this one downstairs. And once I do that, I no longer need the -1 power there. And that's my final answer. Okay? That's my final answer. I want to put it in a nicer way. R1 plus R2 plus R3, right? Let's put that in an orderly fashion. R1, R2, R3, R1, R2, R3. Okay? That's and then we can do more. We can do more. That's the equivalent resistance. That's the equivalent resistance, okay? So solution, I find the equivalent resistance of the circuit below. I'm gonna put it even in a better way in terms of V, R1, R2, and R3, okay? That's what this example is all about. Then we can go the next step. The next step, another example, okay? There's more. Find the main current I flowing from right after flowing right after the battery in terms of V, R1, R2, and R3. That's another problem that we may see out there. Okay? In terms of, and I'm gonna italicize here so it looks nice. In terms of we don't need that, right? Just put a dot here, a period. Put a period here as well. Like that, and then we work out the solution. Okay? Flowing current I right after. What do? We apply ohms. Don't forget, I'm gonna put it between quotes because it's not exactly a quote. Law between quotes. We apply Ohm's law. Okay? Refer to this circuit here. Apply Ohm's law. V is equal to R 1, 2, 3 R 1, 2, 3 I. That's what Ohm's law is all about, okay? We want to find out what I is. Emphasize that here. And I divide the left side by R1, 2, 3. R1, 2, 3, right? We go the next step here. V divided by, now I don't want that in both space. Just copy and paste what R1, 2, 3 is all about. Okay, here you go. And then we can finalize our result by putting R1, 2, 3 upstairs. Like that. That's the final result. And there are more problems. And the more problems, I mean, more difficult with more difficult levels, okay? Let's do another one. That's the main current. Okay? Next. find, here you go, the current I12 flowing through resistors R1 and R2. Okay, find the current I12 flowing through resistors R1 and R2. That's another problem that we can see out there. And we write that in terms of the R1, R2, and R3, okay? Solution. Let's get our drawing first, right? Here you go. This one right in here. Or even better, this one. We can use this one. Yeah. Either this one or the other one. Okay. Solution. Here you go. We want to find this, the current that flows through this arm right in here. Notice that the electric potential at the end of R12 is V, right? Oh, that's not what I want. I want the formula. I want the formula. I want this formula here. Okay? I want this formula here. V is R12 times, now my current changed names to I12. Okay? We want to know, find the current, the main current, not the main current, the current I12. All sorts of examples that we can come up with. We divide V by R12. Okay. And then we R1 plus R2. R12 are in series with each other, right? Recall that R12 is in series with each other for the reason that we have to have this other drawing here, right? And that's the answer we want. And one more. And let's not forget I12 is equal to I1, which is I1 means the current that flows through I1 through the first resistor, which is also equal to I2. Okay, the current flowing through through the first resistor is equal to the current flowing through the second resistor. And the last one, to get everything properly, to finish everything in a proper way, is find the current I3 flowing through resistor R3. That's the next one that's gonna, in terms of V, R1, R2, and R3 if necessary, right? Solution. That's what we want. We have I12 flowing here. We have I3 flowing here. Let's see if I have the, yeah, I can get this one, right? It's better if we get this one here. So you can picture it better. That's part of the solution. And I am going to, here you go. I want to replace this one right in here, like that. Right? Maybe we need this one as well, right? Let's get that here. Yeah, we need that in the other drawing as well. In this drawing right in here. Okay? Let's see if we need another one. Let's see. Okay, and I'm gonna get this one as well. Copy and paste there. In place of this one. Okay. Now let's find out. Don't forget we have a junction right in here, right? And when I'm going to make it an even better drawing, I'm going to make like that because I'm going to rotate, see format, shape, size, and position. Rotation. I'm going to rotate 90 degrees. This guy, I'm doing that because I want to make sure that the length of this arrow ends up being the same as the length of the other arrow. So I am, there's some realism in my, like that. Another student coming in, 10:43 already, yeah? Let me finish this example so you can start the lab. Let's see. Yeah, I want this one here. Oh, and by the way, we don't forget we have a junction here. Or junction. Right? My current is splitting. And the analogy is that at the fork in the road, right? The electrons are the cars in the freeway, fork in the freeway. Just the illustration of the junction. According to the conservation of electric charge, according to the principle of conservation of electric charges, we have that I must be equal to I12 plus I plus I30. Oh, what we do not know is I3, right? Gotta do it again. I3. I'm gonna highlight I3 because I and I12 were found before. Okay, so let's find I12 first. That's I12. Copy, and paste, right? So here we go. That's I12 right here. What the heck happened here? Let's do that again. I12, I12. I12. Right? So all I have to do is to copy and paste right here. And then we also have I3. I3, now we have I, right? We want to find I3. I were found before, right here. And I'm going to copy that. All right. I'm going to number those examples. Example 1. Example 1. Example 2. Example 3. Example 4. Okay? According to the principle of conservation of charges, we have something like that. We found I12. We found I12 from example. Which example? Oh gosh. From example 3. From example 3. From example 3. Okay, so we substitute that. And we get that. We found I from example 2, right? Let's see with example 2. Yeah, it was example 2. Or that's example 2. Copy and paste it. Now we are ready to solve for I3. Now we are ready to solve for I3. We pass the other term to the left side. And let's see if we can simplify this equation. The best way to move forward with that is to combine the two terms with the same denominator, right? So what we can do, we can multiply the numerator and the denominator by R3 to get exactly the same denominator. And now we have to combine those two terms. Okay, and we will end up with a term VR3 is a negative sign. Okay. Yo. We erase that I3. Okay, and now we cancel that with that, see that? And we simplify, we get that. Oh, there's more to it. Here you go. There's more to it. R1 and R2 cancels out, and we end up with this simpler result that comes from Ohm's law, right? I3 is V divided by R3. We get this result because we have just one resistor there at the other branch of the circuit. So, we did everything that we could do for this problem here. There is nothing else. Oh, we can calculate the power, right? But the power really for some other time, because I still didn't cover power. Okay. So here you go. I'm gonna take attendance right now. Any questions? Am I missing any questions from you in the chat window? So practice those problems that are at home. We start with the simpler ones. Okay. So you can get, let's write it down here, right? Make sure you practice these problems at home, right? You start with the simpler, that's how we do it. You don't start with the more difficult problems. Start with the simpler problems and build up to more complicated, more difficult problems, right? more difficult problems. The first thing that you have to do, the first thing you have to do is use Ohm's law, right? With a single resistor. Then you repeat for 2 or more resistors, either in series or parallel. Then you combine resistors in series and parallel in a single circuit, right? That's how you build up in difficulty. Illustrations. Now let's take attendance. See, P07 should be here. Yeah. P38, P07 Lab. Today is the 12th. Let's get this one here. And insert right here. Oh, and let's not forget, right? I should remind you that the exam is going to be next week. Chapters 18 and 19, plus lab number 1. And don't forget, lab 1 is due now, right? Lab 1 is due now. Chapter 20, we are going to leave for the other exam. Yeah, we leave for the other exam. Notes here, 2025. So here go. 1, notes, reminder, right? Lab 1 report is due now. 2, first partial exam is March 19, 25. Okay, just a reminder. And let's go for the attendance. Abir, Ahmad, are you there, Abir?
Yes, I'm here.
Thank you. Next is Nestor Alvarado.
Yeah, I'm here.
Okay, thank you, Nestor. Next, Monte. Monte just joined us, right?
Yeah, sorry, I was having some internet issues, but I'm here.
Okay, thank you. Hasti. Where is Hasti? I don't see Hasti in here. Next is Isabella. I don't see Isabella either. Okay. Let's see. Next is Justus Bowden.
Professor, I'm here.
Okay, thank you, Justus.
Thank you.
Barmistrova.
I'm here.
Okay, thank you, Alexandra. Benjamin Carvajal. Okay, thank you, Benjamin. Brianna Carrillo. I don't see Brianna here. Nope, no Brianna. Elizabeth Castellano. I see Elizabeth here in my Zoom roster. I need Elizabeth to reply. Looks like Elizabeth is away from her computer. So next is Natalia Cordoba. I don't see Natalia here either. Next, Jacqueline Delgadillo.
Here.
Okay, thank you, Jacqueline. Next is Jenny Diaz. I don't see Jenny Diaz here. Looks like Jenny also missed last time. Valerie. Hello, Valerie. Valerie is not here. Next, Juan Escalera. Juan is not here today, right? You missed. Okay. Bianca Eulaki. Bianca Eulaki.
I'm here.
Thank you, Bianca. Dana Gomez.
Here.
Thank you, Dana. Edwin Gonzalez. I don't see Edwin here. Next is Ellie Gonzalez.
Here, Professor.
Thank you. Manuel Hernandez.
I'm here, Professor.
Thank you, Manuel. Samantha. Is Samantha there? Samantha Hubbard. Let's see. Samantha. No Samantha. CJ Houghton. I don't see CJ here. Okay. Next is Luis Leal. Luis Leal is not here either. Amber. I don't see Amber. Amber Lopez, right? Yeah. Next is Areli Lopez.
I'm here, Professor.
Thank you. Genesis Lopez. Genesis.
I'm here.
Thank you. Mary Michaelian.
Here.
Thank you, Mary. Ramon Olivares.
Here.
Next, Taylor Horn. Okay, thank you, Taylor. Jeremy Pittman. Hello.
Yep, I'm here.
Okay, thank you. Stephanie Ramos. I don't see Stephanie. Okay. Next, Leslie Rios.
I'm here.
Thank you. Jason Street.
Here.
Thank you, Jason. Hema Torres Navarro.
I'm here, Professor.
Thank you. Let's see if we have the numbers match what we have here. 24. 24. Doesn't match. 25. So, well, I'll keep watching that. Okay, good. That's 11 o'clock right now. Let's have our break. Break from 11 a.m. to 11:15 a.m. Okay. See you in 15 minutes. I'm back here. Let's quizzes, assignments. Okay, we have this assignment for lab 1. And now we are going to have an assignment for lab 2. Okay, so let's get a new assignment here. Lab 02. That's going to be due, not next week, because next week is the exam, right? So let's make it due 2 weeks from now on the 26th. Okay, I'm putting here 11:59 p.m. Okay, so the lab 1 is not due right now. It's due until the end of the day. I'm gonna make it available today. 26. Okay. Let's see, save. I have to publish too, right? Let's publish. And then I go where I go here to grades, I believe it. Yeah, assignment. Okay. So now I have to upload. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16. Okay, 33. Actually, we have 20 students, right? So let's see how we're going to do that. Yeah, that's great. Submit for students. Abahau coming. Let's see. Submit for students. Yeah, I gotta drag it file there. Lab reports. Nope. I gotta put it this elsewhere. Lab goes here. Raw data. Lab 2. And sign. Okay. Copy. I like to duplicate these files. So copy. So I can play with them during the class. Whereas the others remain in the format that I want you to receive. Let's make sure everything is correct here. Looks like everything looks good. I first put them in, let's see. Someone is asking me, I'm not sure if my message went through earlier, but I'm here and presenting. Okay, so let's see. Elizabeth Castellan. Let me check, Elizabeth. Yeah, okay, good. Thank you. Thank you for letting me know. Elizabeth Castellan. Okay. 5, that's good. Okay, so let's see here. Looks good. Looks good. Looks good. Looks good. Oh, wait a minute. This one doesn't look good. Okay. Those, don't forget, those that are in red, you do not need to worry about the significant digits, okay? But everything else seems to be all right. Yeah, Significant digits not required, significant digits not required. Okay. Good. So now I'm going to start distributing the spreadsheets. A total of 80, of 34. Okay, so the first Ahmad already have your spreadsheet there. Let's see next, Mr. Now, Mr. Your spreadsheet is in there as well, Mr. Oops, what's happened here? Yeah, your spreadsheet is in there. Now let's go for Monte. Monte has the spreadsheet there. Next in line is Amin. Amin is not here, right? Yeah, Amin is not here. Okay, so let's skip Amin. Isabella. Isabella is not here either. Let's skip Isabella. Justus Bolden. Justus Bolden. Justus is here. Submit. Next in line is Alexandra. Alexandra is here. Yeah, Alexandra is here. Next is Benjamin Carvajal. Next, Elizabeth Castellano. One, two, three, four, five, six, seven. One more. Next is Natalia. I don't see Natalia here. Next is Jacqueline Delgadillo. Yeah, Jacqueline is here. One next is going to be Jenny. Jenny is not here, right? Jenny is not here. Valerie is here. Or not. Yeah, I don't see Valerie here. Next, Juan Escalera is not here either. Bianca. Bianca is here. Now, next. What's going on here? Nothing wrong here, right? It's not uploading. Let's try it again. Ah, strange. Submit. Looks like it didn't go through the first one. Okay. Next, Dana. Dana Gomez is here. Yeah. Submit. Next, Edwin Gonzalez. Edwin Gonzalez is here. I don't see Edwin. Next, Ali. Ali Gonzalez is here. Next, Manuel Hernandez. Manuel Hernandez is here. Let's see how many we have. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. That's good. Samantha. Samantha is here. Nope. CJ. CJ is not here. Luis Leo is not here. Amber. I don't see Amber either. Arely. Yeah, Arely is here. What? Next is Genesis. Genesis. One. Next is Mary. Mary is here, right? Mary is here. That's good. Next is Ramon Oliva. This is Ramon Oliva. Yeah, Ramon is here. Next is Taylor. Taylor is here. Next, Jeremy. Jeremy is here. Stephanie Ramos. Stephanie Ramos. Leslie Rios. Stephanie Ramos. Oh, it looks like Stephanie Ramos is not here, right? Yeah, Stephanie Ramos is not here. Leslie Rios. Okay. Jason Strait. Jason Strait. Next, Emma. Emma is here. Yeah, Emma is here. And everybody should have their spreadsheet, with the exception of those students that are not present. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, okay. Okay, so going back here to our lab 2, 3, 12. Right? I want to know if you have received, if you have downloaded. What you have to do, you have to download your lab 2. Okay, so Abir, did you download your lab 2? Hello, Abir. Okay, Abir is not answering. Let's go to the next one. Nestor Alvarado, did you download your lab 2? The
Yeah.
spreadsheet? Okay, good. Thank you. Next, Monte. Did you download the spreadsheet for your lab 2, Monte?
Yes, I did, Professor.
Okay, thank you. Asti is not here, right? Asti is not here. Isabella Ballestero is not here. So let's see. Justus, did you download your lab, the report or the spreadsheet for lab 2? Hello, Justus. Okay, I'm gonna put a star under his name. Alexander. Okay, what did you say? Did you download the spreadsheet? Okay, good. So yes. Next is Alexandra. Hi, Alexandra. Did you download your spreadsheet?
Yeah, I downloaded it.
Thank you. Benjamin Carvajal. Thank you. Brianna Carrillo. Did you download your spreadsheet? Brianna is not here, right? Yeah, Brianna is not here. Elizabeth Castellano. Did you download your spreadsheet?
Yes.
Thank you. Natalia. Let's see. Natalia is not here. Jacqueline Delgadillo, did you download your spreadsheet, Jacqueline? Okay. I see Jacqueline here in my roster, but I don't hear from her. Okay, so let's start here. Start her name, Jenny. Jenny is not here. Valerie doesn't look like she's here either. Yeah. Juan Escalera. Juan's not here. Bianca Eloki. Did you download their spreadsheet?
Yes. Yeah, I have it.
Okay, thank you. Dana.
Yes, I have it.
Okay, thank you, Edwin. Edwin is not here. Wait. Ellie Gonzalez.
Yes, I downloaded it.
Okay, thank you. Manuel Hernandez. Hello, Manuel. Okay, I'm going to start here under Manuel's name. Samantha is not here. Joseph CJ is not here. Luis Leal, Amber Lopez, not here. Arely, you download their spreadsheet, Arely? Arely?
Yes.
Thank you. Genesis, did you download
I
their
can download it, but it doesn't go to Excel.
It doesn't go to Excel?
No. And neither for my last lab. I don't know why. I tried everything and it won't go to Excel.
What are you using? Are you using a Mac? Are you using Chrome?
A Mac. I'm on Chrome.
Oh, on a Chrome. Yeah, yeah, yeah. Try to get a different computer, like a Windows, because I had problems with Chrome in the past.
I'm not gonna buy another computer for it.
Well, you can use the
I
computer.
have an iPad and I have a MacBook.
Uh-huh.
And it won't download. It downloads as a regular file, but not to Excel. I'm not sure what to do.
Yeah. Did you try to access those computers there at the library, Lee Harbor Library?
No. No, I haven't.
Yeah.
Oh, Professor, I'm here and it worked for me. Manuel.
Who is that?
Manuel?
Manuel Hernandez, right? Okay,
Yeah.
so good. So yeah, try to get access to one of those computers, okay, that are Lake Harbor, so you can do your lab work, okay? And that's the best I can suggest you. Did you use the Microsoft Office we get? Yeah, so Gemma is asking you, Genesis download. Okay, so I'll put the note here and let's go for Mary Michaelian. You
Yeah,
download?
it works.
Yeah, it
Yes.
works. Okay, thank you. Ramon Olivares.
Yes, I downloaded it.
Okay, and you are able to open too, right?
Yes.
Okay, thank you. Taylor.
I downloaded it.
Okay, and thank you, Jeremy. Let's see, Jeremy. Jeremy is no longer here, huh? Yeah, okay, so I'm gonna put a no here and left, right? He was here earlier, but now he left. Stephanie. Stephanie is not here. Leslie.
Yeah, I was able to download it.
Okay, thank you. Jason Strait.
Yeah.
Yes, okay.
Yes, I have it.
Okay, good. And Hema.
Yeah, I was able to download it.
Okay. So the student, Stephanie, you're here, right, Stephanie?
Yes, I'm here.
Okay, so did you download the spreadsheet?
The new one, yes.
Yeah, the new one. Okay, so attendance here. Okay, it's not much different from the other lab. It's just we do have a different configuration. Okay, I'm gonna show you what is the configuration. It's nice that we can work with this type of sheets, okay, with different electrode configurations. So let's see, there's not this one lab slide. That's what I want. I'm gonna show you E field 1 and E field 2, right? So you can compare one with another. Spreadsheet, that's E field 1. Okay, the electrode configuration of the first lab was this one, just as a reminder. Okay, see the parallel plate, right? At this point in time, you should memorize that the electric field for parallel plate is uniform. Okay, up to first approximation, with exceptions of the edge effects, right? With the exception of edge effects. And by the way, we do use this type of configuration devices, okay? Like a parallel plate, for instance, the old TV screens, the old computer screens made of CRT, the cathode ray tube, which was invented in the 19th century. Those old CRTs tubes for TVs and computer screens, they use a parallel plate inside of it to steer the beam of electrons that goes to your screen and that paints the picture in your screen, okay? So I'm not talking about something that's far off there that nobody uses. No, we do use that in practice. In practice, we do use parallel plates that are uniformly charged. You know, those things have practical applications. Now, for lab number 2, what we are going to do? We're going to use the same resistive paper. Yes, it's the same resistive paper, but it's going to be a different electrode configuration. The electrode configuration is going to be those concentric circles. They are concentric. They are not shifted, okay? We made sure that it's concentric, so we have a nice distribution of equipotentials, a symmetric distribution of equipotential in this case. That's why, okay? And so that's the situation we have. We have the black piece of paper, the resistive paper, in which we paint two circular electrodes with a metal paint. We use a metal paint to do that, one concentric with the other. Next, We put the resistive paper on the top of a corkboard. We use a corkboard because it is a dielectric. I'm going to put it here between parentheses, dielectric. Oh, and by the way, I have to start documenting the materials that we use, right? So here you go. Lab. Here you go. Lab 2, E-field 2. Okay? So, resistivity paper. Resistivity paper. Right? Draw 2 circular electrodes. No, let's see. Resistivity paper. Yeah, let's see. Conductive pen. Okay, conductive pen. That's the material that we are using here. Materials. List of materials. List of materials. Resistivity paper. Conductive pen. Okay. And procedure, right? Let me write down the procedure. Procedure. 1. Draw 2 concentric circles on the resistivity paper using the conductive pen. Okay, that's the procedure here. It's not 2 concentric circles, right? It's like, okay, draw a disk, right? A disk at the center of the resistivity paper. It's better this way. It's a disk, it's not a circle. And a circle concentric to the disk using the conductive pen. Okay. So you're going to need also the corkboard. Okay. Place the resistivity of the resistivity paper. Here you go. Place the resistivity paper on the top of a corkboard. Okay. Who's coming? Jerry. Place the resistivity paper on the top of a corkboard. We're just repeating the same thing that we did before. The only difference is that going to be the different, we're going to use different, a different electrode configuration, okay? Next, insert 4 pins to the edges of the paper to secure it on the corkboard. Let me close this one here. I'm closing the other one as well. Okay, so 4 pins, either plastic or metallic. Okay. And then we have here the procedure. You know, fix the edges of the paper to the corkboard using the 4 pins provided. Okay. That's, so see, we have a list of materials, right? And we have a procedure that they follow side by side. And that's the pins that I'm mentioning here, 1, 2, 3, 4. insert one pin anywhere along the outer electrode. Okay, that two metal pins. We're gonna need two metal pins. Two metal pins. Insert one metal pin anywhere along the outer edge, the electrode, along the electrode at the outer edge, along the outer edge electrode. Like that. Okay. Insert the other metal pin at the center of the disk electrode. Okay. So that was the next one here. Okay, but then you have to make sure both metal pins make full contact the surface. Make sure the lower surface of the metal pin makes full contact with the electrodes, okay? And what do I mean about that? Okay, I mean the following. You do not want these metal pins, a fraction of the metal pin touching the black paper. You don't want that, okay? You make sure that the whole metal pin makes full contact with the electrode. In both cases, both this one and this one, you do not want anything like that. You do not want anything like that. Okay? Otherwise, you're not going to get a good contact there. You're not going to get a good charge in there. And also the charges are going to interfere with your electric field that you're going to map in this black paper. Okay, that's the insert another. What's next? Next, turn on power supply. Okay, well, we need a power supply as well. Two metal pins, one power supply. And what do you do with this power supply? Turn on the power supply, right? Turn on power supply and adjust it to 10 volts. Okay, adjust it to 10 volts. Next, connect the outer electrode to the negative polarity. Let's put here polarity of the power supply using the black cable and the alligator clip. Okay, so we're gonna put it here. Black cable, alligator clip. Alligator clip. Okay, connect the outer electrode to the negative polarity of the power supply. Using the black cable and the alligator clip. Okay. The moment you connect the negative polarity of the power supply to this electrode, the electrode becomes negatively charged. Okay, you can, just like we had before, right? It's not much different than what we had for the parallel plate lab. Next. Okay, so here you go. We're going to need a red cable. Now we're going to need a red cable, and another alligator clip. So we need 2 alligator clips. Let's put here 2 alligator clips. Connect the inner disc electrode to the positive polarity of the power supply. The positive polarity of the power supply has a red color. The negative polarity of the power supply has a black color. Using the red cable and the alligator clip. Okay, and now, the inner disc becomes positively charged. Now that we have this positively charged region and this negatively charged region, we have an electric field that are emanating from the center of this configuration. Can you picture that? Lines of the electric field pointing towards the outer circle. Next, connect one end of the second black cable. Oh yeah, now we're going to use a second black cable. So you can put it here. 2 black cables. 2 black cables. And I'm going to, okay. 2 black cables. Connect a second black cable to the outer circle of the electrode. To the outer electrode, let's put this. To the pin in the outer electrode. The second black cable, right, is going to be connected to digital multimeter DMM. Okay, connect one end, right? One end of the second black to the pin in the outer electrode. To the pin on the outer electrode. Okay. Connect the other end of the second black cable to the negative polarity of the digital multimeter. Okay. Next, we did that too. Connect the other end to the outer electrodes. It doesn't matter what the order here. One can be done before the other. Either one can be done before the other. Connect one end of the red probe to the red jack. Okay. For now, leave the other. Connect the one end. Okay. Now we need to connect one end of the second red cable. Let's put it to the jack, right? To the red jack, to the positive jack of the DMM. So let's put, instead of negative polarity, yeah, okay. Instead of polarity, let's use jack. Okay. And here, connect one end. It's not the second cable. It should be probe, red probe of the multimeter, of the digital multimeter. It's not a cable, but it's a probe. It's a probe made of a cable. Connect one end of the red probe to the positive jack of the multimeter. Leave the other end of the red probe and you lose anywhere on the black paper. Okay, this probe will not be fixed for the remainder. This is the only remainder of the experiment. Here you go. Next. Leave the other end of the red probe laying down the table. Okay, so set an imaginary x-axis through the middle of the paper. Okay. Imagine set an imaginary axis, horizontal axis, through the middle of the black paper. Another student here. Just like you go x-axis. Think about that. Next, we are going for our break very soon. Set an imaginary y-axis along the vertical direction, passing through the center of the black paper, right? Set an imaginary vertical axis through the middle of the black paper, passing, right? Okay. Passing through below the black paper. What else? Let's finish that and then go to the break. You go. I'm just walking you through how the experiment is performed, X and Y. I think we can stop here because it's going to be the actual experiment. We finished the setup. We finished the setup. Next, we will check out our equipment. There's a checkout procedure here. And then we will start the actual experiment. Okay? So we have those 3 steps. 3 steps is to set up the equipment. We're going to do the checkout of our equipment to make sure everything is working. And then we will start the actual experiment, okay? And we will do that after the break. 12 noon, from 12 noon to 12:15 p.m. Any questions? Okay, so I'll see you in 15 minutes. I am back here. And now we have 2 students, right, that joined us. Make sure you download the spreadsheet for lab number 2. Okay, one of them is, let's see here. Pittman. Pittman is Jeremy, right? Jeremy. Make sure you download. Make sure you download your spreadsheet. Did you download your spreadsheet, Jeremy?
I'm doing it right now.
Okay.
Sorry, my internet's been in and out, so.
Okay. And someone else trying to join us. Carvajal. Okay, so let's continue with our procedure here.
I'm here too, Professor.
Who's that? Edwin, right?
Yeah,
So let me see. Edwin, what's your last name, Edwin?
Gonzalez.
Gonzalez, right? Okay, so attendance here. Did you download your spreadsheet? No, right?
Yes.
Are you sure? I don't think I
The
posted.
spreadsheet?
Yeah, the
Or we're
last.
talking about if it's a new one now.
Yeah, the new one. The
No.
new one. Let me see if I posted in there. Gonzalez. Edwin Gonzalez. Oh, yeah, I didn't. Okay, so let me get you the spreadsheet. Edwin Gonzalez. Lab correct. Yeah. Let's see. Lab 2. Okay, so I upload that for you, Edwin.
Perfect. Thank you.
Does everybody have the spreadsheet? Just let me know. If you don't have it, let me know.
Yeah, I can't find mine either.
You cannot find your spreadsheet? Let's
Yeah.
see. The lab 2. Oh, it's here, okay. Am I sharing the screen with you? See, Jeremy Pittman. Okay, so I did upload it. It's supposed to be there. Lab 2. Okay, go to Canvas and look for your lab 2 spreadsheet. Okay. Everybody, I understand that most of you have the spreadsheet. Let's go to our let's see. I'm gonna show you more or less. Let me get my multimeter, okay? So I will demonstrate how we do the checkout of the equipment. Okay, I already did that before, but I'm gonna show to you again. Okay, here is my fancy multimeter. I bought it. When did I buy this multimeter? I bought it 2006, I believe. Okay. I'm going to stop sharing so you can see the multimeter more clearly. There are, like I said, there are a bunch of multimeters out there. There's just one of them. Okay, there are larger multimeters. This one's a small one, but there are larger boxes that behave like a multimeter as well. Okay, the probe that I'm talking about is this one here. The probe that I'm talking about. That's so inconvenient what I did here. There are two probes, one black and the other red. Okay, black means negative polarity and red means positive polarity. Okay, so the black goes to the black cable goes to the black jack of my multimeter. Okay, And this probe, this black probe or cable, can be a cable too. Okay, is going to be fixed at the edge, at the outer ring of my electrode. This probe here is going to be fixed at the outer ring of my electrode. The red cable, the red probe, okay, is going to be connected to the red jack. We're going to measure voltage. So in this case, we use this jack here that says specifically that we're measuring voltage. The other red jacks here is not for measuring voltage. The other two jacks here is for measuring current. Okay, that's why I'm connecting to this one here. It's very important that you learn how to work with this type of device because it can help you finding out all sorts of things. Okay, this device can help you find out which battery of yours is uncharged. Okay, if you have a problem in your electrical installation, this multimeter also can help you figure out what's happening to your electrical installation at home and so on. Okay, although I don't recommend you do that by yourself because your electrical installation at home has high voltages and you can get hurt. So it's better to hire a professional to do that. But whenever it comes to low voltage batteries, like 1.5 volt battery, 9 volt battery, it's okay for you to do that with your multimeter, okay? And those experiments too, since we're dealing with low voltages and low current, you can, do that by yourself. Okay, so the black probe is going to become fixed, is going to stay fixed at the outer ring of my electrode, the negative electrode of the paper. It's going to be fixed. The one that's going to be movable is this one here. This one here, we're going to use this probe here to find out the different voltage that are written in your spreadsheet. Okay, but before we get there, we have to do the checkout of the equipment. We're 3 steps, right? 3 steps. First, setup of the equipment. Second, checkout of the equipment. Third, the actual measurement. Okay, I'm going to write down, I'm going to organize that accordingly. And now I'm going to share the screen again. Here you go. And I'm going to 3 different steps. Those steps, everybody does those steps. Astronauts, when they go to orbit to deploy a space telescope, they go throughout the same procedure, okay? When they were deploying the Hubble Space Telescope, they were going through this procedure. They're doing the checkout of the Hubble Space Telescope. When they launch a satellite, they do the checkout of the satellite. Engineers, astronauts, everybody does that. And even technicians and students like us, like you folks, right? And professionals like me. So procedure, let's see here. So 1, setup, right? That's the first step, setup. And then what comes next is not gonna be number, it's gonna be lettered. B, C, D, E, F, G, H. Okay, all those steps that I document here, I'm putting in a different format because now we finished the setup. Okay, so now it's going to be checkout. Checkout phase, right? And then we have the actual measurement phase. Actual measurements phase of the experiment, checkout. The checkout phase is just some rough measurements that we do to ensure that not everything, but most of things are working correctly, okay? Most of the things are working correctly. So the checkout phase consists, a very simple checkout phase of the experiment consists of 1, check out your equipment. As a check to your equipment, touch the red probe on the pin of the outer electrode, okay? So you're going to have the black probe on the pin of the electrode, and I'm going to approach the red probe to the same electrode that the black probe is. When we do that, you are supposed to read 0 volts in your multimeter, because those two probes are exactly at the same equipotential. When they are exactly at the same equipotential, the difference in voltage at the same equipotential is going to be 0, by the way. Okay? So that's the first check. This probe is touching the pin, the metallic pin in the negative terminal, in the negative electrode. This probe is going to touch the pin of the negative electrode as well. And you should read 0 volts. What do you read? Okay. And then we're going to write that down. Check out, touch the tip of the red probe to the pin on the outer electrode. You are supposed to read 0 volts in your multimeter, in your DMM. If you don't read 0 volts, that's because there might be something wrong with your experiment. You can read, slightly less than 0 volts. Okay, you can read like 0.01 volt, that's okay. But if you start reading 1 volt, 2 volts, maybe that's because there's something wrong that you have to troubleshoot. Okay? That's one step for the checkout. There's not a lot of things that we do, okay? In the next one, as a second check, touch the red probe at several places along the surface of the outer electrode. We are talking about this region here, okay? This region here. First, we touch the red probe at the pin, and now we are touching the red probe at several places here along this electrode. And you should read 0 volts as well, or something very close to 0. Okay, let's touch the tip of the red probe to the surface of the outer electrode. You are supposed to read something close to 0 volts as well. Okay? My goodness. You can read, you can read 0.01 volts. That's okay. And that's okay. Okay? You can even read, you can even read 0.1 volts, and that's still okay. And that is still okay. The problem starts when you read 1 volt or more, okay? If you read 1 volt or more, you have to troubleshoot your experiment. You have to troubleshoot your setup. Make sure, no, that's too much, right? Here we go. Next, what's next? It's just 4 steps for this checkout. Next, as a third check, touch the red probe on the pin of the inner electrode. Now you're going to get the red probe. You're going to touch the pin here at the very middle. The black probe is going to be touching the pin of the outer electrode. The red probe is going to touch the pin on the inner electrode. Okay? And if you do that, you should be able to read 10 volts. Okay? Third check. touch the tip of the red probe to the pin of the inner electrode. You are supposed to read 10 volts because you set up your power supply to 10 volts, right? Somewhere here I said that, yeah, right in here. Turn on your power supply and set and adjust it to 10 volts. Okay? And the last check is touch the red probe on the surface of the inner electrode, not the pin, but the surface. This surface right in here. You should also read 10 volts. Okay? Force check. Touch the tip of the red probe to the surface, on the surface, right? On the surface of the inner electrode, not the pin, the electrode. You are supposed to read 10 volts again. So those are the 4 checks that we do. Okay, and now we are ready to start the experiment. Data, actual measurements. Okay, do you see that? The setup procedure goes from A to P, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 16 steps. Okay, I'm going to put setup 16 steps. Checkout 4 steps. Okay, and then actual measurement is several steps. 12:33, we have another 17 minutes to go, right? It's really scary out there, folks. I'm here in my home in Brazil, and it looks like we're having a thunderstorm out there. I can hear the wind. It's so strong. I'm kind of scared at this very moment. Tá ventando forte lá fora, não tá? It's the wind is very strong here. And I am the 9th floor, I'm the building in the 9th floor. I'm really, it's concerned. So if you think I'm looking funny here, that's because I'm a little bit scared, okay? It's not gonna happen anything, but thank you, Benjamin. But, if something bad happens, I'll let you know. I don't think anything bad is gonna happen, but. Okay, so let's go for the actual measurements right now. Think about I am now the 9th floor building, and the higher you are, the stronger the wind, right? And we are having a thunderstorm out there, and the wind here is very strong. I can't hear it. It's slamming through the building. It's really scary, and at the same time, it's also funny, because at the end, nothing happens, right? At the end, nothing happens. Okay, now we are going to do the actual experiment. Okay? I asked you to come up with imaginary x-axis here, imaginary y-axis, because I'm going to use them in my experiment. Okay? The first measurement that we are going to make is to find the coordinates of the first point that indicates half of a volt. Okay? Half of a volt. First measurement. First measurement. Find the coordinates of the point, of a point, okay, along the imaginary x-axis, right? Imaginary x-axis that reads 0.5 volts, okay? You're not going to get exactly 0.5 volts, but you're going to get that very close. To get exactly 0.5 volts, It's lots of work. So I tell my students, don't try to get exactly 0.5000 volts. Just get something as close as you can, like 0.4953, it's okay. But that's what you're seeing right in here in this slide, okay? Lower voltage right here. Here is 0 volts, right? So as we move towards the positive charge in the center of the paper, you should read an increasing in voltage, okay? So that's your first measurement along the x-axis. And so let's take a look at one of the spreadsheets that you have in there. Okay, let me get spreadsheet of group number 3, right? Spreadsheet of group number 3. I'm going to, here we go. See, that's the column for half of a volt, okay? This group here measured 0.507 volts, right in here at the top. But wait a minute, I want this one here, where x is equal to 0, okay? Here's x is equal to 0. And that's the first point that they got. 0.502, just not exactly 0.5, just 0.502, which is okay. Let me see here. Oh, wait a minute, I'm sorry. Along that, here's the first point, okay? This is the first point. It's not x equal to 0, it's y equal to 0, okay? Y equal to 0. Y equal to 0 corresponds to a point along the x-axis, right in here. Y equal to 0 is a point along the x-axis, right? That's what I tell my students to do in this. And then the next point, what they're going to do? You're going to get the 1 volt point along the x-axis, okay? I'm proud of this procedure. Okay? I worked out, nobody taught me how to do this way. I figured it out on my own, okay? So here you go. The next point along the x-axis is going to be a voltage equal to 1 volts. In this case, 1.024, okay? Y coordinate equal to 0. X coordinate equal to whatever, 6 centimeters and a half, right? 6.4 centimeters. Here is, for half volt is 7.3 centimeters. And then you repeat for 2 volts. Okay, for 2 volts. For the next one, for 3 volts along the x-axis, 4 volts. And 1, 2, 3, 4, 5. I usually ask my students to get 6 equipotentials, 5.5 volts. Okay, 5.5 volts. So here we go. I'm going to spell out the procedure. Okay, first measurement. Find the coordinates of a point along the imaginary x-axis that reads 0 volts. Along this axis, y is equal to 0, right? Repeat 3A for the following voltages. Half, right? We did for half. 1, 2, 3, 4, and 5.5 volts. Okay? All along the x-axis. And again, just to, here you go. Those are the measurements along the x-axis that I mentioned to you, okay? 5.5 volts. Y equal to 0, Y equal to 0, Y equal to 0, and so on, okay? And then we do the next thing that's easier. The next thing that is easier, what is the next thing that's easier? We're going to get the points along the y-axis. See what I did here? Okay? Along the y-axis. Find the y coordinates of of the points that have half volts, 1 volt, 2, 3, 4, 5.5. Okay? So we can write it down like the following. Repeat 3A and 3B for the axis, for the let's see, for the measurements, for the same measurement, right? Same measurements along the y-axis. Y-axis means what? X equal to 0, right? That's what we did here. 12:40, right? 10 more minutes to go, so we will continue this experiment next time. Looks like we're not gonna be able to finish. Okay, but let's stay around until the next 10 minutes. Hopefully I will be able to finish the procedure, right? Repeat 3A and 3B for the same measurement, for the same voltage measurements along the y-axis. Okay? And now that you have the basis of your measurement, now you get everything else in between and even past, right, the y-axis, for a total of 6 points. What are we going to do? We are going to get 4 more points in between here, this arc. Okay? Notice that this arc here is larger than this arc, which is larger than this arc, which is larger than this arc, and so on. Okay? And so here you go. What you're gonna get? Here you go. Half volt, right? Get the coordinates of half volts along this outer ring, right? So here you go. Repeat now. Locate. Now find the coordinates for 4 more points of 0.5 volts along the arc between the X and Y axis. Okay, that's what we are doing. And we are going to do for the rest. Half volts. Let's see. You don't want something like that, okay? You want evenly spaced like that. You want evenly spaced, not something a bunch up here and another bunch up in there. That's what I tell my students. No, and then we repeat for 1 volt. Repeat for 1 volt. Repeat step 3D for 1 volt. 1 volt. Right? What else? And then when we start getting at 2 volts, you're going to need to start invading the second quadrant, okay? You need to start invading the second quadrant. Above 2 volts, you know, get at 2 and 3 volts, get 1 point in get just 1 point in the second quadrant. Let's write it down this way, okay? Repeat 3D for 2 volts. Let's see, but get the fourth point, the coordinate of the fourth point, the coordinate of the fourth point in the second quadrant, right? Repeat 3D for 2 volts and 2 and 3 volts. But get the coordinate of fourth point in the second quadrant. Okay? Repeat 3F for 4 volts and 5.5 volts, but get the coordinates of the fourth and fifth points in the second quadrant. Do you get the idea? Okay? That's what I did. 2 points here in the second quadrant, 2 points here in the second quadrant. That corresponds to 5.5 volts, and that corresponds to 4 volts. 1 point in the second quadrant, another point in the second quadrant, corresponding respectively to 3 volts and 2 volts, and so on. Okay? It's 12:46 right now, and you can go back here. Yeah. So here you go, along the x-axis, along the y-axis, everything else in between, right? Everything else in between. Wait a minute. Everything else between plus another point in one, just 1 point in the second quadrant. Everything else in between plus 2 more points in the second quadrant. That's what you have here. Okay, and that's what we have. Any questions? We are going to, we'll have to continue that next time. Okay. And just like we did for the first experiment, and I'm gonna take a look. Don't forget, make sure to upload your spreadsheet for the first lab. Okay, I'm going to correct the spreadsheets, and I will discuss with you next time the correction. Right, I will correct the spreadsheets for the first lab, and I will discuss them with you next time. Okay, to make sure you understood everything that you did. Any questions? 3 more minutes to go. Yeah, we can finish earlier today, right? That's a good place to stop. Look at your data there at home, get familiar with your spreadsheet, right? And be prepared to do the graphs that we're going to do next time. Okay, and I'm gonna change the date, the turning date of the lab number 2. I'm gonna change that. Okay, instead of next week, it's gonna be no, wait a minute. Yeah, you have to be the other week, right? Because we're going to next week is gonna be the exam. Let's see, let's write that down here. Go. First exam March 1925, right? Finish second lab on March 26, 25. Okay, lab 2 do the following week. Lab 2 do the April 2nd. That's what we, unless we have a holiday, right? 48, we have, let's see, we have a holiday on April 2nd. Let's see, we finish lab 2 here. No, April 2nd is not a holiday. Okay, yeah, that's what we have. Finish second lab on 26, lab 2 do, you know, and I will discuss the correction of lab 1 on March 26 as well. Okay. Okay, 1 minute to go. Okay, we can finish now. I'll talk to you. I'll see you again next week, right? See you then. Bye-bye.
Professor.
Yeah. Who is that?
Professor?
Yes.
For the I don't know why it won't download on my computer. Like it downloads but not to Excel, so I don't know what to do.
Uh-huh. Yeah, you have a Chrome, right? You told me you have a Chrome and an iPad.
No, I have MacBook and I have Safari and Chrome on there.
Uh-huh. And you cannot open the spreadsheet with the Mac, is that right?
I can open it, but it won't go to Excel.
Okay, so do you have Excel installed in your Mac?
No, I just have it I have it installed on my iPad. I have Excel on as a regular, like, I can search it up, and it's logged in with my Microsoft account.
Okay, so you have to have Excel installed in your Mac, okay? That's your first step.
Mm-hmm.
You're telling me that you don't have Excel installed in your Mac, right?
No, not on my Mac.
Yeah. You in order to open with your Mac, you will need to have Excel installed in your Mac. The iPad, you do have Excel installed in the iPad, is that right?
Yes.
Okay, but you cannot open with the iPad, is that right?
No. Like, I don't know if there's a way that you can share mine from
Yeah.
Excel so I can open it.
Yeah, let's do that.
Maybe it'll be easier.
Yeah, let me stop sharing my screen with you, and I will give you.
I think I'm group 7.
Okay, go ahead. Now you can share your screen with me, Genesis.
Okay. Let me see. This is on my iPad.
Your iPad, okay.
Hold on, let me make. You can't see anything, right?
Not yet.
Okay. Let me just go to my.
Go to the bottom, right? Click the share bottom middle of the Zoom window.
Sorry. Screen. 3, 2, 1.
Okay.
Can you see?
You're sharing the screen. Okay, I can see my face. Okay, now it's your desktop. Good.
Yeah. So I'm right here.
Show me. Did you show me the Excel file in your iPad? I want to see the Excel file in your iPad.
Okay.
Where is it?
I'm looking for it right now.
Lab 1 and Lab 2, right? Submitted.
This is the file,
So
and I go right
you
here.
opened. You opened, right?
Uh-huh.
Okay, so you're opening, right? So now
Mhm.
zoom in. I wanna see a larger. Okay, so so it looks like you can open with your iPad. You said
Yeah, I can open it, but it won't go to Excel.
you won't go to Excel. So let me.
Yeah.
It seems to be in Excel right now. Let me see. Highlight. Let's see if you can do any highlight any. Click one of the cells. No, not the cells with numbers, but the cell without number. Okay. The cell without number. Do you see student 1 here on the left side?
Mhm.
Okay. Click on the cell next to student 1. Click on the cell next. Did you click it?
I'm clicking student 1. It's just a screen. Like, I can't edit this screen.
You can't? Okay. So
No.
let me see. Where is Excel installed in your iPad? Show me where Excel is installed in your iPad.
I have installed.
Okay, double click on Excel.
Well, I need to add.
Did you click Excel?
Yeah.
Okay, but I don't see the spreadsheet.
Yeah, it doesn't go to my spreadsheet. Unless I try at the school's computer, but that would be until tomorrow. I go to Cal State LA, so I could try there.
Yeah. Try.
I'm taking classes at LA Harbor, but I have in-person classes at Cal State LA.
Cal State LA. Okay. Let's see. I'm trying to understand why you see that. Which folder is Lab 1 and Lab 2 is in your iPad? Do you know?
Lab 1 is just Lab 1 downloaded in my Notability app.
Uh-huh.
It was like, let's see. It like downloaded here.
Okay.
This is Lab 1.
Can you edit this file?
Like, yeah, I can edit it because it's on my own app. Like, I can write on it and I can like type on it.
Okay. So click on the cell next to student 1 and type your name there.
Okay.
The cell next to student 1 and type your name there. Go ahead, Janet. But that's not. You're not. Okay. We see what's happening here. This is
it's not on Excel.
Yeah, it's not editing. This is not editing. So
Yeah.
I do not know why it shows this picture, okay? I do not know why. But I presume, I'm not familiar with iPad, but I presume the iPad is organized in a similar way that a Mac or a Windows computer is organized, right?
Yeah.
You do have folders like the download folder, right? In the iPad, do you?
Yeah, it's on files.
Show me the download folder. Oh, okay, good. Show me where's the lab 1 and lab 2.
That's what I don't. Like, I don't know why it doesn't even go to there.
I'm suspecting that you did not download lab 1 and lab 2.
Cause on my iPad, on my computer, I download it on here.
Huh.
Let me see. Let me try lab 1 again. So I go here and I try to download it. It just says share, and I put save to files.
Save file. Where does it save it? It looks like it's in the cloud, right?
iCloud. Okay, I just saved it.
Yeah, but I want to know where. Can you move this file to the desktop of the iPad?
Like, what do you mean?
Like put the spreadsheet lab 1 and lab 2 in the desktop in that main.
Like together?